All right, so let's look and see what we have. The first thing you did was you drew your structures, correct? So lithium has 2 energy levels because it's on period 2, right? So Li, 2 energy levels. I have 2 on the first energy level, and lithium I have 1 on the second, correct? The next one that I have chlorine. Chlorine has 1, 2, 3 energy levels. I have 2 on the first. I have 8 on the second. And then the last one I have 7, right? Okay, so how many atoms do I have for lithium? I have 1, right? How many do I have for chlorine? I have 1. How many valence electrons do I have for lithium? 1. How many do I have for chlorine? 7. Electrons transferred from to each atom. So we had one electron transfer from lithium to chlorine, right? How would we specify it here? How did you specify it? So I'm going to say I would do lithium has 1 that's going to transfer to chlorine, right? So they're donating it to chlorine. Ions formed in this product. So what do we have? How many ions are formed? 1, right? All right. Ca to O. All right, so go ahead and draw your Ca on the paper now. I just wanted you to do it on board one time just to practice. Thank you for asking. Are you good so far? Okay, if you feel good, go ahead and do the next one. Now this one's a little bit different, right? Because if we look, Be has 2 valence electrons. Fluorine has 7, right? Well, if we look, fluorine only needs 1. So since it only needs 1, we're going to have 2 fluorines to take the other one, right? So this time, we're going to have in our product, we're going to have one of the first one, and then we're going to have 2 of fluorine. There's 2 valence electrons, 1 valence electron. BE is going to donate 1 apiece to each fluorine. So there's going to be a total of 3 ions formed, because BE is going to be happy, fluorine is going to be happy, but for it to be happy, you have to have 2 fluorines. Does everybody understand? Everybody good? Are you ready to move on to number 4? Okay. Number 4, we have Mg and we have S. Magnesium has 3 energy levels. We've got 2, 8, and 2. Sulfur has 3 energy levels. We have 2, 8, and 6. Based on that, we have 1 apiece, 2 and 6. Magnesium is going to donate its 2 to sulfur. We're going to have a total of 1 of each atom when we get done. The last one, potassium, has 4 energy levels. It's 2, 8, 8, and then we have 1. Fluorine has 2 energy levels. We've got 2 and 7. So there's 1 apiece. 1 valence electron compared to 7 valence electrons. K is going to donate its 1 electron to fluorine, and they are 1 K and 1 F. When you get that done, flip over to the back. So we have aluminum, which has 3 energy levels. 2, 8, and 3. Chlorine, we have 3 energy levels. 2, 8, and 7. And when we have our product, we're going to have 1 aluminum, and they're going to take each one of their valence electrons and give it to a chlorine. So that's going to give that one. It's going to have another chlorine and another chlorine. So that 3 valence electrons, one's going to go to this chlorine, one's going to go to that chlorine, one's going to go to that chlorine. We have 1 atom of aluminum, and we have 3 atoms of chlorine. Valence electrons for aluminum is 3. Valence electrons are 7 for chlorine. Electrons transferred to each atom. We're going to have 1 electron to each atom. Ions form. There's 1 aluminum and 3 chlorine. So far, is this making sense? The next one is Na. Na has 3 energy levels. We have 2, 8, and 1. O, oxygen, has 2 energy levels. We have 2, and we have 6. So based on that, it's going to tell me that I'm going to have 2 NAs. The reason why I have to have 2 NAs is because I only have 1 valence electron on that one. I only have 1 valence electron on this one. And my oxygen only has 6. So if they donated 1 here, this one donates it here, then they all have 8. So I end up with 2 sodium. It has 1 valence electron. I had 1 electron transfer to each for our oxygen. There is only there's 2 sodiums here. Oxygen, there's only 1. I have 6 valence electrons. And on oxygen, I have 1 ion formed to that product. Is everybody good so far? The next one is lithium. Lithium has 2 energy levels. On lithium, I have 2 on the first energy level and 1 on the second. Nitrogen, I have 2 energy levels, but I have 3 valence electrons. And so this time, we're trying to figure out what our product's going to be. So, are you okay, Mr. Harris? You need something? Huh? No, I'm talking about Project Leaderway. No, I'm good in here. It's Project Leaderway, the center ones. Everybody's facing, I mean, they're just all 3 in a circle and they just all talk. That's what, when I saw you in here, that's what I thought it was. I'm sorry, Hannah. Nitrogen does have 5. Thank you very much, ma'am. They do have 5. So, I have 1, 2, 3, 4, and 5. Lithium has 1, correct? Now, if I'm looking, I know it needs more than that 1 that it's going to give, right? So, we could do the crisscross here, could we not, to prove this? So let's try that. Lithium has a +1 charge, correct? Nitrogen has a what? Yep, -3. So based on that, it should be Li3, right? N. So that is telling me that I would need 3 lithiums to make nitrogen happy. Does that make sense? Okay, so now you're going to draw the illustration for that. Lithium, 2 energy levels. The second energy level, I only have 1. Nitrogen has 2 energy levels. On that energy level, I have 5. If that gave me 6, 7, 8. Perfect. So, lithium, now, how many atoms do I have? I had 1 to start with, right? Okay. How many valence electrons did I have for lithium? 1. How many did I have for nitrogen? 5. Lithium transferred their, right, 1 to the nitrogen, but how many did it take? a total of 3, did it not? Nitrogen only needed 1. Am I going too fast? Because if I am, I'll slow down. Good. Go ahead and start doing the next one and do it come back. Okay. Magnesium and fluorine, right guys? Okay. So if we did the charges, which would be the easiest part, right? Mg has a +2 charge. Fluorine has a -1 charge. So that would be MgF2. Correct, guys? We can prove that from the Bohr method. Mg has 1, 2, 3 with 2 electrons valence. Fluorine has 2 and it has 7. Based on that, magnesium would take its 2. Fluorine only needs 1, so 1 would go there. I would need another fluorine. It would transfer there. So I have 1 magnesium, 1 fluorine. I had 2 valence electrons, 7 valence electrons. Magnesium transferred to fluorine. At the end, I had 2 magnesiums and, 1 magnesium and 2 fluorine. Thank you, baby. So what you're doing is we're just going one step further, where you're taking the ionic reaction and you're predicting the product. Okay? We're using the cation and anion crisscross method, and we're proving it through the Bohr method. Do you feel confident enough to do the last of them by yourself? You want to do it by yourself, or you want me to help? Okay? All right? So, Na. Na has 3 energy levels. My acid energy level is I have 1. Fluorine, I have 2 energy levels. The last energy level has 7. I know based on the charges, Na is a +1, fluorine is a -1, that my product's going to be NaF. So based on that, Na will donate us 1 electron to fluorine. So I have 1 Na, 1 fluorine. I have 1 valence electron, 7. I know that Na is going to donate to fluorine. I know I have 1 and 1. Aluminum has 3 energy levels. The last energy level has 3 valence electrons. Oxygen has 2 energy levels. The last energy level has 6 electrons. Aluminum has a what type of charge? +3. Oxygen has a -2, correct? So based on this, it tells me I'm going to have Al2O3. Is that what y'all decided? To prove that, we're going to do our aluminum. Valence electrons is 3. They have 3 to give away. Oxygen has 2 energy levels, and it has 6. So based on that, how many valence electrons do I have for aluminum? 3, right? How many does oxygen want? Oxygen just wants 2, don't it? Okay? No, it's fine. So if I gave one of it here, well, I still have one left, don't I? So then that means that if I do another oxygen, and if I need that many, how many does aluminum have left to give me? Only 1. Is that going to make me happy? No. So I'm going to have to draw another aluminum. With that aluminum, that gives me another 3, right guys? So if I give that one away, guess what? I still have 2 valence electrons that still want to find something. So for it to be happy, it's going to have another oxygen, so those 2 valence electrons would go somewhere. So I had 1 aluminum, 1 oxygen. Aluminum, we said, had 3 valence electrons. Oxygen, we said we had 6. We know that aluminum is going to donate to oxygen. To end up with, I'm going to have 2 aluminum and 3 oxygen. Is everybody ready for the next one? Alright, so we have lithium. So lithium has 2 energy levels. We have 2 and 1. Oxygen has 2 energy levels. That is 2 and 6. Okay, so based on that, I can do my charges. My Li has a +1. My oxygen has a -2, correct? So my product is Li2O. So that's telling me I have 1 valence electron, but my oxygen needs more than 1, doesn't it? So then I would have to have an Li and another Li, and then I have only 1 oxygen. That one would donate 1, that one would donate 1. So I have 1 and 1. I have 1 valence electron, and then we said lithium had how many? 1. How many does oxygen have? It has 6, yeah. So we know that lithium will donate to oxygen. I ended up with 2 lithium and 1 oxygen. I'm going to leave you to do the other 2.